Hi and welcome to this video about writing a Windows service. In the previous video we've seen what Windows services are and looked at some services tools and so on, and I promised to show you how to write a Windows service. Let's do that now. So the first thing we're going to do is to write a minimal Windows service that can only be started and stopped, just the bare minimum to see something that works, and then we'll add some functionality to it so it won't be completely boring. So here I'm in Visual Studio. I'm going to create a new project. We'll start with a console application. I'm going to call that Simple SVC. I'm going to put it in some directory like YouTube code. I'm going to later publish on my GitHub. And then we'll create this little console application. So this is a normal console application. Doesn't seem to be any different than any other console application. In fact, it is exactly that. The thing that turns it into a service is calling certain APIs. Let's go ahead and have include here for Windows, and we'll see if we need other includes. So the first thing we need to do in order to turn this thing into a service is to call the function start service control dispatcher. This function registers a bunch of services to be hosted in this process. So you can have one, which is a typical case, but you can have more than one. And you can see here in the IntelliSense, it requires a pointer to something called service table entry. So in fact, we have to create an array of that thing. And we need to have at least two entries. One of them is for one service, and the other one is a sentinel value indicating that there are no more entries. And that's the only list of services that we have. So we need to provide the service name. We're going to have a global variable here for that because we might need to use that multiple times. Let's go ahead and call that the G service name and give it the simple name simple. It seems like a good name as any. Let's make it properly an array. So of course, this is what it's going to look like. And then we can write here the entry. Let's just click F12 here to see what's going on. There are two things here. We need to provide a service name, some kind of string, and a function. And this function is going to be called the main service function, which is going to be automatically launched by the service control manager infrastructure within our process. So first we have this service name. So let's go ahead and add that in, and then we have a function. Let's call that simple main. We'll see what is required of it, and then the next entry is going to specify null to indicate that it is the end of the list, and we need to pass this array to this start service dispatcher control dispatcher function. If this fails for some reason, then something went wrong, and it'll just return -1. Otherwise, we'll return 0. In fact, this function never returns, or actually it does return once all the services in the process are stopped. So this function will not return, but it will call our service main function. This is the main function for this specific service. If I had more services, then there would be another main function for a different service here. And so the question, of course, is what is that function going to look like? So again, going back here, we can see that the service function has this prototype, and this is just this kind of function. So we can just grab and copy paste it. We have a function returning void, and then a win API. We can call it whatever we want, which is a simple main in this example, and it requires these parameters. In fact, it gets the parameters which allow us to customize how this particular service is running by providing kind of a command line arguments of sorts. But we're not going to use them in this little example. So what should we do here? So the next thing to do here, this is the function that's going to be called by start service control dispatcher. For each service we register, we need to register something called a control handler. This is another function whose purpose is to take commands from the service control manager, such as stop or pause and continue, things like that, and execute them as appropriate. So for this purpose, we need to call another function called register service control handler. We call this function to provide the service name. So here's the service name. And then the handler function itself. Let's call that simple handler, which of course we'll have to write. And the return value from here is something called the service status handle, which I'm going to keep as another global to make things easy on myself, because we're going to need that later on, perhaps in other functions. So we have this thing that represents the service here. So it's kind of a special handle used for the service. Now, before we write the handler, we need to do, we'll do a few more things. So in this case, what happens, the simple main function is going to be invoked, and the scum is going to wait for some report from the service, whether the service is successfully started or maybe not so much. So the thing is that we have to call a function called setServiceStatus. And this setServiceStatus thing allows us to tell the scum what is the status of the service right now. And especially when starting, the scum is pretty impatient, which means that we have to start the service to bring it into the running state as soon as possible. And once we start doing any kind of initialization, we want to tell the scum, hey, we're in a start pending state right now, and we'll report the final status very soon. So we have to, from time to time, if initialization is lengthy, to update the scum. As you can see, this function setServiceStatus requires a service status handle, which is the thing we got back from register service control handler, so we're definitely happy about that. And then we have the status to report, which is another structure called service status. So again, since it's going to be useful to call this function multiple times, I'm going to have a global variable for that. And we want to here provide the service and then the status, which we have to properly fill out, of course. And so I'm going to have maybe a simple function for that, to do that for us. Let's call that setStatus. That's going to accept just the service, well, in fact, the actual status of the service. And that's because most of the structure has fixed values, but some things are changing. In fact, the main thing that changes is the status of the service. So I'm going to call setStatus, and I'm going to say here that service is start pending, telling the service control manager, hey, I'm now making some preparations. I'm going to initialize stuff now, and then once I'm done, I'm going to tell the scum that I'm ready to go, which is by calling the same function with service running. Of course, in this example, the initialization is really nothing. We're not doing anything just yet. So I could have just called setStatus to service running and forget about it, but we'll add initialization here very soon. And so if that could take some time, it's best to tell the service control manager that we're aware of the fact that we need to start and it shouldn't be too impatient. So we have this call here. Before we're able to implement setStatus, of course, the actual code is rather simple here. So we have the handle to the service. We made it global for simplicity, and the status is also global here. And we need to initialize one member here. It's going to be the address of status here. So the thing that actually changes, that is not the same all the time, is the current state. And this is exactly the status, so let's call that state to be more consistent. That's the current state of the service. That's going to be here, start pending, and then later on it's going to be service running. Now, in order to make this properly work, we have to initialize some members of this service status, which we can actually do just before calling start service control dispatcher. So let's see what we have here. The data structure is zeroed out because it is a global variable, but a few things we need to perhaps give it here. One of them is the service type, which is something indicating whether our service is part of a shared process or of the fact that it's using a process just for itself. So we have the own process case here. We have just a single service in this process. The other thing we need to specify is the controls accepted. That is, which kind of controls we are willing to accept from the service control manager. In this case, I'm going to accept the minimal, which is also not necessary, but in this case, I do want to accept that. I want to be able to accept stop. So I want to be able to accept a request to stop the service. Otherwise, the service would be unstoppable using normal APIs. If you press F12 here, you can see you can accept other kinds of controls, such as pause and continue. You want to perhaps notify get notified when the system shuts down, and other stuff that are of course fully documented. For now, we're just going to accept this stop flag. So we have these two setup things already here. They're not going to change for the lifetime of the service, so we can just initialize them once and forget about it. And now we can make the changes here to the status. So the last piece of the puzzle before we can test this thing out is this simple handler kind of thing. So let's go to F12 again and see what that looks like. Here's the function, and the handler function looks like this, which, as you can see, is super simple, just has a control. That's basically it. There's actually an extended function which you can use, but I'm not going to use it in this example because it's just not needed for what we want to do here. So we have our handler function. Let's call that simple handler. And the only thing it gets is the control code. That is, what is the current request we're getting from the scum right now. And it's our mission here in this case is to look at the code that we get and do the right thing. So if I get here savers control stop, which is in fact the only thing I'm supposed to get because I've indicated that's the only thing I'm supporting, then it's time to basically close or shut down the service. So in this case, the thing to do is just simply to tell the scum that, okay, fine, I'm going to call set status and say that the service is stopped. I have nothing to clean up at this point because we haven't done anything. And so this is kind of the bare minimum. This would cause the process to shut down because it is the only service in this process. There are no other services in this process. So the scum knows that there's no point in keeping the process alive if there's just one of those around. So let's go ahead and build that, see if it compiles. So it compiles fine. So we now want to test it. So what we have is just an executable. In order for that to be actually a service, we have to register that. And this can be done using an API such as create service, but we're not going to use the API here. We're just going to use existing tools such as the SC tool, or using something like PowerShell, or maybe some other tools. So I'm going to go to my simple SVC here and x64 debug. This is where our executable is. And now we can create the service. So there's an sc create command we can use. We can give it any name that we want. That's going to be the name that is going to be the key in the registry. So that has to be unique key in the registry under the normal services subkey we looked at in the previous session, previous video. So it's simple. That's almost all that we need. We can add type equals own so the registry values are consistent, but the most important thing to do is to add a bin path, which is where our actual service is. So in fact, this is in this directory. We have to provide a full path here. So we have YouTube code simple svc x64 debug and then simple svc.exe. That's the one. And well, apparently there's an error here, maybe because of an example I did yesterday for myself. Let me fix that by stopping the service first. And it should be deleted right now because I have deleted that, but let's just verify. I'm going to delete that one. It's already have been deleted. Great. So let's go ahead and create it again. And it works. It works just means that the registration has succeeded in the registry. The service is not yet running. Let's just verify the stuff in the registry. So here's simple. You can see that we have here, we didn't provide lots of information in the sc create call, but we still got some defaults. For example, the type here is 10 hex. This is the own process, which we did specify. Start here is 3, so by default this is manual start, and this is why it wasn't starting automatically. Object name is the user to run under. I didn't specify anything, and the default happens to be the local system account, which is going to be fine for our purposes. And here's the image path. That's the path we actually have to provide, because without that there's no meaning to the service. And then we have error control here, something I mentioned briefly in the previous video, but didn't really talk about. This indicates what to do if the service fails to load or the driver fails to load. The same thing applies to drivers. And just like in the case of star, there's a range of values from 0 to 3. 0 being the simplest, indicating do nothing. 1 is the most common, indicating write an event to the event log, and that's it. And there are more severe values, 2 and 3, which are mostly appropriate for certain critical drivers and critical services. I'm not going to cover that here to save some time. So at least in terms of registration, everything seems to be fine. So now we can start the service. We can also use the services applet just to verify that indeed it is recognized. So let's see if we can find it. Here's simple. We didn't provide any particular description or something, so that's why we don't see anything here that is very perhaps interesting, but that's what we expect to see. You can see the manual start here in local system being the user. We can double click and again see all this stuff. We don't see any kind of description, of course. We can see that it uses the local system account. There's nothing special in terms of recovery. These are all registry entries we could have entered manually or using the tool, and there are no specific dependencies. We can of course start the service from here. That's also something that should work, just like it should work with using the SC command. So you can see here it says running, which means we have succeeded. If we open Task Manager, we can see simple SVC is running. It's running on the system account as we expect. It is live. Now, if you want to stop it, we can go to the same tool and do that, but we can go to the command line just for variance. We can use stop here by providing the name that we gave to the service, that is the key in the registry, and it should shut down, and it does. So everything is fine. We can also start it back, which we're going to use the command here instead of using the GUI, which is simply just faster. And again, it starts up, everything is fine. Okay, great. So we have the first step working for us, and in fact this is kind of the bare minimum you need to have a service that is functional. It's not very interesting, not doing anything interesting for now, but at least it is functional as a service. So now let's add something to make it a bit more interesting, and what we'll do, we'll have this service provide a logging support. So we'll be able to use that as like a singleton logger on the system to log messages of one sort or another. And the way we're going to do that is by exposing some communication entry point that other processes can connect to and say, here's a log message, here's some information, please log that kind of thing. And we can do that in many ways, of course. We can expose a named pipe, we can expose some COM server entry point, we can expose a socket, we can do all sorts of things. What I'm going to do here, I'm going to expose a mail slot. A mail slot is like a mailbox. It's a one-way communication mechanism. So the service is going to expose a mailbox with a known name, and applications can write to this mailbox a certain format that is going to be expected, and that's going to write some log into a file being managed by the service. So this is what we want to do here. So the first thing we need to do in order for that to work is to initialize the mail slot, and also to create a file which is going to serve as our logging target. And so let's go ahead and do that by creating a few globals. Again, I'm going to use globals here just for simplicity because it's just so easy to share them. So I have a logger handle here and a mail slot handle here, which is going to be our way to expose communication endpoint, which by the way can also work across machines, so we can do that from another machine, send a log there, but it doesn't really matter here. So the first thing to do here is to take the mail slot and create a mail slot. That's a mail slot server. We're creating the server part of the mail slot. We can give it a name. It always has to be something like this with a mail slot here, and then whatever name we want. So let's say logger, like so. This uses the UNC convention, so we're essentially doing that on our machine, and that's the proper way to create a mail slot. And then we have some message, maximum message size we don't care about, some read timeout which we don't care about, all the defaults are just fine, and then we'll just go with the default security, at least for now. And then we're going to also create the logger file. That's going to be a normal file. This is where everything is going to be written to. It's not going to be accessible from the outside world. Only the mail slot will be accessible from the outside world. So the first we need some kind of name. So let's just go ahead and use some temp here, like I don't know, a service logger.log or something, or whatever. And then we have the access. I would like the ability to append data to this file. In terms of share, I don't want to share this file at all. I want to have exclusive access to this file. No specific security to specify. We get some default security, which is going to be fine. The creation disposition, we're going to use open always, which indicates that if the file exists, let's just open it. If it doesn't exist, let's create it. And then we have some flags we don't care about, and a template file we don't care about either. So what happens if something goes wrong? So if this returns invalid handle value, it means that the creation failed. And the same goes with the hlogger. If that returns invalid handle value, then again, something went wrong, which means that we need to report that in some way, perhaps, which we're not going to do here, but we're going to stop the service, because without that, we can't really do anything. So I'm going to say service stop. That's going to be our status, and we're done. There's nothing really we can do beyond that, and the service will stop, and since it's the only one in the process, it will also shut down. Once we have that, then we can start doing something with the mail slot. Before we do that, let's go ahead and do some proper cleanup here. So if we are asked to stop, let's just go ahead and properly close the handles to both of these file objects, the file and the mail slot. Just to be nice, doesn't matter that much because the process is going to shut down, so the handle is going to be closed anyway, but still, it's a good thing to do that. And now we, here in our service main function, so we're saying, okay, the initialization is done. So you can say to the service call manager, it's okay, we're in a running state, so everything is fine. And now we want to do some stuff to be able to accept messages using the mail slot that would indicate that there's something to log, and then just log it. And so for demonstration purposes, let's do something which is not super completely trivial, but just to make it slightly more interesting, let me add a header file here, and let's call that simple svc.h, or maybe logger.h, maybe that would be more appropriate. And then we create something that represents a log message. So a log message is going to contain, let's say, a log level. So let's create an enumeration here called log level. Let's say we have something like critical, error, warning, info, and then maybe debug or something. Doesn't really matter here. So the message is going to consist of a log level and a text, just some kind of text that must be null terminated. Let's call that text. I'm going to use 1 here just to indicate that it could actually continue with any number of bytes there, as long as they're null terminated. This is how we're going to expect this message to be provided to us. So let's go ahead and add and include here for our logger. And this is something that also will be needed by client applications, because they will need to have those definitions so they can work with those. We can even put the mail slot a name there if you wanted to, but let's just continue for now. So the next thing to do here is to start listening on the mail slot. So we're going to call the function get mail slot info. This is a way to ask whether there's something that has appeared in the mail slot. That is, there is some kind of message waiting. So first we need the handle to the mail slot. Then we can get some information back from the API if we care. The max message size, I don't care to change that. The next size is actually going to be interesting, so I'm going to grab it. And then how many messages we actually have. So let's call that messages. And then the read timeout, which I don't care about and I don't mind waiting forever. So we have here two things we need to grab back. We have the size of the next message and the number of messages. So once we get some kind of response, we need to deal with the information. And the first thing is to check whether the number of messages is 0 or, well, actually 0, the size is 0, or the number of messages, there's a special value called mail slot no message, which indicates there are no messages. And in this case, we can just continue and wait for the next notification from the mail slot. Otherwise, it means there is some kind of message waiting, so I want to read it. So I need to have a call to the read file function. I'm going to call the read file function. Of course, read file is a generic function that calls from whatever handle to a file object we have. In this case, this is our mail slot. So we want to read that we're in the server side of the mailbox. We're going to get data or messages coming to the mail slot, which is like a mailbox. So the buffer here, we have to prepare some kind of buffer. Let's do that. Let's just create a buffer here with, let's say, 1 kilobyte in size. I think that's going to be good enough for our purposes. So we need this buffer. Here it goes. We need to read size number of bytes, because this is what we were told the size is. And obviously here I'm neglecting the fact that if I get too big a message, I won't be able to read all that, and I'll get an exception. It's not going to be very good, so I probably should allocate the buffer dynamically, and I leave that as an exercise for you. I want to make things as simple as possible, not to make this video too long. It's going to be long as it is. And then number of bytes we actually read, and it's going to be a normal synchronous operation. So I'm going to read that and look at the information returned here, the number of bytes read. If indeed we read a bunch of bytes, which we expect to read, but let's just verify just in case, we want to write the log message into the actual file. And what we want here is to add the timestamp for when that actually happened. So the first thing I'm going to do here is to grab the local time, which is going to be returned to me using a system time structure, which is very convenient from display purposes, because it has these various constituents of date and time, like the hour, the minute, the day, and so on. So it'll be easier to use. And then we need to look at the message itself. So the message is supposed to be a log message structure. Again, I'm not doing any verification here for that. I'm going to assume that client applications are nice and doing the right thing, again, because it's not really the point here. I want to demonstrate the services aspect and not really the full programming aspect, how to do that properly. That's going to be for you, the interested viewer. So we expect to have a message here, and that message is supposed to contain the log level and whatever text is required. So we need to also prepare some text here for the message. Let's just prepare another set of bytes here and use the sprintf function to put here message is probably not a good thing here. Let's call that output. So we need to prepare the output to use. And what we want here is, say, to provide the time. I'm not going to provide a date just because I want to save time, and we're going to just test it today. So that's going to be the time here. It's going to be an hour, minute, and second, and even a millisecond here. And then we can provide the actual textual at the log level and the textual message itself. That's what I want to output into the file. So in order to do that, we have to do some work here to get all the information in. So here's the hour, here's the minute, and now we need the seconds and the milliseconds. We have that as well, so why not take advantage of that? Then we need the log level. So let's have a little function, or maybe not a function, just an array, log levels, which is going to be the index that we're going to get from the log level here. That's level. I'm going to have this little array to convert the enumeration values, which are just small integers, into the actual text. And then finally, we're going to get the text here from the message. So we're going to use sprintf here to dump all that stuff into a string, and then into an array, and then we can just go call write file on our real file, that is the logger, open a handle there, and use output here as our output buffer, and the length is going to be the string length of output. And the number of bytes written, we need to get it back because it just must, and that's basically it. So we've written the file, the output here into the file. Let's just make sure that we have all the stuff ready. So we have written here, we're just missing the log levels. So let's go ahead and create that. We just create that as a simple array. Let's do that. And what I want to do here is to just take the log levels that we have here and make them a string, just like so. So we can do some maybe quicker editing here, just so that we have something more interesting in the log besides the actual text. So we have these values there, so it's just going to map the values of the enumeration into an appropriate string. Let's see what else we're missing here. So sprintf here, it doesn't seem to be very happy, so maybe we'll add something like stdlib to make maybe string or something to make sprintf happy. Apparently it's not happy still. Maybe stdio will make it happy. Okay, good. So now we have that, and in fact we have an infinite loop here that's going to be just listening to mail slot stuff and output whatever it gets into the log file. So that's fine, and that's fine because once the handle to a mail slot is going to be closed at some point when the service stops, this function will fail and return false and will break out of this while, and everything would be good enough. So let's run this, make sure everything works, at least compile. So we have some warning here, not really that interesting. So now no warnings, great. So we can launch the service, but of course at this point nothing is going to happen because we're not going to really write anything to the service. We have to create some console application or some client application to use the functionality of the logger. So let's go ahead and do that. So another console application here, let's just call it app, something very not very perhaps imaginative, but good enough for our purposes. So what we want to do here is to use this login service. Now in a real service you probably would create some API for that. You'd create some kind of API that would have a function, say like log message, something like nice to use, that would be exported in some DLL, and you'd be able to use that without having to know anything about the actual mail slot. But we don't have time for that. So I'm going to create a handle to the mail slot in order to send it the messages directly without creating a wrapper API, but feel free to do that. And so we need to provide the same name. Since we're going from the same machine, we don't have to provide any machine name here. But if you would come from a different machine, if that application would run on a different machine, you have to use here the correct server name in order to get to that machine. And what we want to do here is to be able to write to this logger. That's a mail slot. You can always write to it. You can't really read from it unless you're the server. The share mode doesn't really matter because it's always an existing mail slot here. Security again means nothing because it's not really up to you. We're just opening a handle to an existing object really. And so we have to specify open existing because it must exist. There's no way to create it using the create file call. Only create mail slot can create a mail slot server. And again, some uninteresting flags here and null here. If that fails, then something is wrong. Maybe the service is down. That could be an error. That could be a problem. So error opening a mail slot. And that's one reason why this might fail. But could be others. And we'll see that. So here's a little check here. Once we have that, we want to just write a bunch of messages just for demonstration purposes. And so let's go ahead and do that. So first, let's have a little loop here that will write, let's say, 10 messages, just to demonstrate that this works. First thing we do is to perhaps sleep a little bit. So I'm going to call getTCount 64 and just do something like module with 700, which means sleep anything between 0 and 699 milliseconds, just for fun. And then we can go ahead and use sprintf to generate some message. And I want to have a message here that takes advantage of the current process, just to make something that is perhaps easier to view and see that things are coming from different processes and potentially threads. So let's see how we're going to create our message here. So what we're going to do, we're going to need to have some kind of log message here. That's the same structure we've seen that is really for client consumption as well, not just for ourselves. So we have this logger.h where the log message structure has been defined. So we have this message here which we need to fill out. But in order for this to work properly, we just have here the single character. We're going to need more than that. So let me just create a local structure here as a little trick here and have like a buffer here that would have more characters we can use. 500 should be good enough. And let's call that message. So I'm going to fill out this message here with the text, message with the message internally, which is going to have the text buffer here. So because this is a structure, it's going to have more characters to extend that actual message. So let's write something like this is a message from PID and TID. So let's just write something that is going to be coming from a particular process and thread to see something interesting. So we have here get current process ID and get current thread ID, like so. So we have this message being formatted and n is returned as the number of characters actually. So we can leverage that when writing to the logger. Let's call write file. So writing to the mail slot. This is what we do with the mail slots. So we have the logger here and we're writing the buffer, which of course is what we have here in MSG. This is the log message itself. A number of bytes we need to write is, we could use the size of the buffer in its entirety. It doesn't really matter that much. We can also use the calculated information. So we can have n and also add the size of log message. So make sure we get the header part as well with the log level. That should be good enough. Number of bytes written doesn't really matter, but we just need to grab this information anyway, and we're done. So let's add a D word here for written, and that should be good enough. So let's build that, see if that compiles. Seems to be compiling fine, so let's go ahead and try it. So the first thing we need to do here is to start the service, of course. So let's go ahead and use se start, and our service is called simple. So it started. Well, we can verify by using query, for instance, see if it indeed was started successfully. It has, because we had this little initialization there in between. And now we can run our application and let's see if it works. And you can see it doesn't seem to work. And we have error opening the mail slot, and the error is number 5, which you might recognize as an access denied. And so we have an access denied here, and that's because the mail slot is very well protected being opened by the system account, because this is how our service is running. So by default, the default security, even though it says null, it just means default security, and default security only allows the system account proper access to the mail slot, which means you need to make it more accessible to clients, because clients don't have to run with admin privileges, don't have to run with a system account. In fact, we want them to run in normal accounts. This file itself, the actual target of the logs, this is fine to be completely under the control of this process, the service, so it shouldn't be able to be accessed by others, but the mail slot should be, because this is our communication endpoint. And so in order to do that, the simplest thing to do is to remove any protection from the mail slot. So we're going to create a security descriptor here. I'm going to initialize it by calling initialize security descriptor. Let's do that. And we're going to initialize this security descriptor and it's just a fairly standard descriptor that provides the revision, which is just a constant number. It just initializes that as an empty security descriptor, and what we want to do is set a security descriptor DACL, which is the way to specify who can do what with the object. We want to say here that there is a DACL, but its value is null, meaning it's an empty DACL. An empty DACL means that there is no protection. So in order to apply that, we can use security attributes, which we typically don't use. We provide null in the call to create mail slot, but now we are going to use it. I'm going to initialize the length here to the size of, and then we have the actual security descriptor like so. This is what we need to do, and then pass here this security attribute structure. Once we do that, then we should have a mail slot which is not really protected, so anyone can access it. Just to verify, let me open Process Explorer here, just to prove that what we're talking about here, of course, doesn't compile because the service doesn't link properly because the service is still running. We didn't shut it down, but I want to show you the what is happening here. So let's go to our simple SVC here. You can see there is a bunch of handles here. One of them should be our nice mail slot. Here goes. That's device mail slot logger. That's device mail slot is the internal device name that manages mail slots. So if you double click that and go to security, you can see that the system account has, well, all access. Administrators have, well, some of the access, and they don't seem to be able to have a modify that is a write access, and that's why it's not working. Even though I was running as administrator, because this command window is running with admin privileges, we know that we can't control services from a standard user rights, but even that wasn't good enough. And so what I want is completely, just for simplicity, to remove the security on this mail slot. So let's go ahead and try that. So first thing we need to do is to stop the service. Okay, it stopped. So now the process should be just going away, just as we expect. And then we can build that to make the updates, and we can then go ahead and start it again. So now, before we actually test it, we can go to simple SVC again, see the handle to the mail slot. Now, if you go to security, you can see it says no permissions have been assigned to this object. Essentially, this object is completely unprotected. Anyone can access it, which is fine. This is essentially what we want, because this logger mail slot is supposed to service provide service to any process on the system. So now, when we use app here, we expect things to perhaps work better. So I have some exception here saying that the buffer is too small, and that's probably on me, because I've just did some stuff here with the buffers, which is probably not something that I should have done in this particular example. So I have here a buffer, and I've used the fact that this is an array to provide the size. That's the wrong thing to do, actually. So I actually have to write something like this, like size of message. That's going to be my maximum thing that can accommodate. It's not really taking the information from the array of just one character. That's definitely not the thing that I'm expecting. So let's try it again. Apparently I have another silly bug here. That's kind of annoying, but hey, sometimes that happens. Let me just use that very simple thing to say that 500 bytes is what I'm able to accommodate. That should be fine this time, I hope. So let's do that again. Okay, so we have error opening the mail slot. It says file not found. That's kind of weird, because it means that the service is not running. Right, so the service is not running, and that means that something failed, and that's because I passed some bad buffer to the service and it crashed. So that's on me again, because I haven't done any validation. So that's on me. Okay, trying this again, and apparently I'm keep getting this error. So the service keeps crashing on me, and that's because I messed up here by not providing the proper level here. That's the thing. There was a garbage value there, and then the code that failed was the one that gets to this particular array. It gets some garbage value, which read some garbage information, and then just crashed. So that was completely my bad. It just crashed on my other screen, and I just I realized I forgot the level. So I want to have some random level here just for fun. So let's go ahead and do something like use again get, just going to cast that to log level and use a value here, which is going to be get tick count 64 again, and then we need to modulate that with number of log levels that we have. So in order to make it easier, let me add here another entry called count that I can use for the modulo operator here. So log level dot count, like so. And again, I'm going to have to cast it again for the compiler to be happy. That's going to be good enough. And now, hopefully that would work. So let's see. First, we need to stop the service. Well, actually, we don't have to stop it. We just need to try it again, but just for verification, let's just start from scratch. We have a stopped service. We can start it, and then we can finally run app and hope for the best. So now it should run for a few seconds based on the randomized sleeps that we have here. And now we can, well, actually I didn't compile that again, but it doesn't really matter. I didn't change anything in the service. And now we can just look at the file there. So we have the file, the temp service log something, or simple log, or whatever I call that. Let's just go ahead and open that and see what we have. So that's SVC logger. Here goes. And we get an error here. We're not able to access the file. And the reason is because we didn't provide the proper sharing. And so if you look at the sharing, the way we open the file here in the service, here's the opening the file here, the actual log file, that is this file. We didn't provide any kind of sharing, which was probably too much. So what I can do in this case is at least I can stop the service, and then we can start the temp, we call that SVC log or something, and we'll be able to see the log. So here's the log as we expect it to show, like something similar to this. But to make it better for the next run, we can definitely change that to file share read. And so if anyone wants to read the file at the same time, I'm okay with that. So now we can start the service again, and we can run app. And while the service is running, we can go ahead and try to open the file again. And now it should actually work. It should probably work, but start tries too much. Maybe just need to use Notepad directly or open that from Explorer. Okay, it seems like if I just double click, it opens just fine. There's no issue there. The start probably tries to do something a little different, maybe trying some other application. So anyway, we can go ahead and just reopen the file a number of times here to see the messages appear. So that's an example of a service. We had some hiccups here. In order to debug these things properly, we might need to do some more work. Of course, this is just a simple example to try to fit to a certain length of video. But hopefully you get the idea of how to create a service, how to manage that. Once we indeed stop the service, then we won't be able to send any more messages at this point, because the file is being properly closed and the mail slot, of course, is closed as well. But the service is down. And this is a typical way of working with the service. When the service is up, then it listens to some communication endpoint so that it provides whatever service it provides. That's why it's called a service. But once it shuts down, it can no longer provide that particular service. That's why some services in Windows are critical, and if they're shut down, nothing in Windows can really work properly. But most services can be shut down. They don't have to provide their functionality at any given point in time. So hopefully this makes sense. Feel free to play with the code, and you can find that on GitHub as usual.